Okay, so it is currently 12:30, exactly an hour and a half until my first exam starts. The first exam is complex analysis. This isn't the paper I'll be saying, this is last year's paper. But yeah, these are just, I don't know if the person who wrote this exam is the same person who will be writing the exam I'm going to sit, but this is just some of the things that have come up in past exams, so this is fine, just computing real and imaginary parts of a simple function, not too hard. Some path integrals here, that's fine. I've actually attempted this particular question. Part A was okay. B had me stumped for some reason, but then I realized I can just take the derivatives inside the integral there because it's dt, not dx or dy, so sick. I haven't actually attempted C. Let's see, what else we got here? Some more Cauchy-Riemann equations, this will be fine. Some more path integrals, that's just fine. Ooh, poles. Now, I'm not the best at poles, I'll be so honest, or like singularities in general. But I believe for this one, it would be something along the lines of, you can rewrite f as z to the n times another function. So like g of z, for example, where g of 0 is not 0, I think. And then for this one, suppose that the function holomorphic. Okay. Well, if g of z equals z to the n times g of z, I don't know. Well, let's hope that doesn't come up in the exam. I'm sure I'll be fine actually. Oh, this question, Laurent series. This particular question about like endless of convergence, a very similar question came up in an assignment I but a few weeks ago. Instead of a 2, it was a 3, and of course there was a 3 there. So if this kind of question comes up in the exam, I'm very confident I can get most or if not all the marks. I feel like I could lose marks in like not being, specific enough in some small instances. But yeah, 7, more about poles. Let f be a holomorphic function, assume that f of 0 is 0, and f of z does not equal 0 for all z in that disk with z does not equal 0. Just say it only equals 0 when z equals 0. Consider the function g on the punctured disk of 0, 1, given by g of z over . Okay, this seems like what I mentioned earlier about the whole z to the n times another function of z. I think that'd come into play here. Path integral of this, holomorphic function h. If it's holomorphic in that disk, then this integral goes to 0. Then if it's integral of this, then what, just n 2 pi I? 4 marks, so yeah, that seems alright. Then we got the above, but consider a function which is holomorphic. Z rather than a 0. Okay. Again, consider the function. Show that there is a holomorphic function h, so that is that not just like simply rearranging what we did up here, kind of? Am I tripping? It must be similar, right? I feel like the fact that they set up in a similar fashion is meant to show that it's a similar approach. I don't know. Okay, let's see what we got here. Showing that it's holomorphic, that's not too bad. Yeah, cool. Yeah, because z cubed don't equal 0 when z equals 0, so that's just fine. Find the derivative as well, fair enough, just quotient rule. I showed that f can be written as 1 over 2z. Okay, just substituting in, then simplifying, I imagine. Is this path not just a unit circle? That could be a dumb statement, but that seems about right to me. And then the generalized quotient integral formula, that's fine. And then, ooh, dear, what's this? Laurent series. Okay. I must admit, I am spectacularly bad at deriving Laurent expansions. So if this comes up in the exam, I might just pray that the other 3 section B questions aren't too bad. But yeah, I only have to answer 2 questions from section B. There's normally 4 in this exam. And then I have to answer all of section A. Section A didn't seem too bad, but Yeah, well, if you've been watching, if you're with me for a while, you know that last year I was able to bring a double-sided A4 sheet of notes into the exam to make up for COVID. They're doing that again this year, thank the heavens. And this is mine. It's kind of folded up on this side. This side is a bit of a joke because I got lazy. But focusing on the positive, what's we got here? We've got harmonic definitions. Lemma saying that if the partial derivatives of the real and imaginary parts are continuous, we can say it's holomorphic. That's going to help with the CREs. Binomial expansion, Cauchy's integral formula, some trig identities, some Taylor series expansions. I really think I've made this take up too much space on there, but that's too late now. An example of a Laurent expansion of, I think it was sine over z cubed. I believe it was that. That's what I could guess from like the inner workings, but I may be wrong there. And then the classification of the singularities here. Another Laurent series expansion, this time about 0 and 1. What's on this side? What you got here? Oh yeah, some of a geometric series, some solutions from an assignment. Yes, actually that kind of, I forgot about that on there. Is that the exact same question? Oh, well, that surprised me because basically, I don't know if it's the same for all universities, but for my university, they don't release exam solutions for you to like access whenever you want, due to them wanting you to actually get better at maths and not just get better at an exam. So I'm assuming he just copied this assignment question right from an exam. I'm not going to complain. Yeah, some more classification stuff. A proposition that I doubt I really need. This lemma here saying that a converging power series, if you multiply it by n to the k, then it will also converge. Wait, is that what that says? No, I got ahead of myself. I'm talking about what's over here. Yeah, so that's what I'm talking about. This is talking about, what was this talking about? Oh yeah, if a power series converges for a specific z, then for any z smaller than that, it also converges absolutely. Yeah, and the coefficients are bounded by m over z to the, yeah, fair enough, okay. But yeah, how am I feeling overall? For complex analysis, or compared to real analysis, I feel like complex, I feel like it's a bit more abstract, and yeah, I feel like it's a bit more abstract, but like the topics themselves aren't more difficult, if that makes any sense. I could be chatting rubbish. If there's any I don't know, graduates or like postgrads watching this, they could give their input as to what they find easier or harder. What they find easier or harder in undergrad or postgrad or whatever. But yeah, overall, if it's similar to the past paper here, I'm thinking I'll be around a 7.5 or 8 out of 10. If it's not, then it could be closer to a 6 or a 5. But yeah, I will probably make a second video once I finish the exam and I brought the paper home to take a look at it. But yeah, that is it for now. Wish me luck.